morning, everybody. I'm Matthew Festo from Open Robotics, or as Jingbing kindly introduced me yesterday as the local Matt, because we had two of us up here on the stage, so it was great. I'm going to talk today about open source providing energy to the ecosystem that we work in. And I think Christoph in his speech yesterday actually used a perfect word that I have in here in my mind, which is open source and ROS is the fuel that's driving Industry 4.0. And so that's a theme of the talk today. So we're all familiar with the biological definition of an ecosystem, right? It's a diverse group of life forms that somehow create a healthy system that we all work together well, or that all works together well. We're going to talk today about a digital ecosystem. And so from a concept standpoint, it's the exact same. This definition and the picture is from Wikipedia. But the concept of it is that we're working in a diverse group of systems and solutions and providers that all can thrive together. Open source, closed source, doesn't matter. So enough about biology, we'll talk a little bit about robotics. At the end of the day, a robotics system is a composition of sensors and actuators that interface with the environment, and behind all of that is some stack of software. And software is hard, right? It's difficult, and it's the brains behind what is happening in the robot itself. So we need, if we're going to have robots working in the world today, we need the support and the infrastructure and the tools to enable these robotic solutions to support the hospitals and all the other environments that robots need to operate in. So on the next few slides, I'm going to be an equal opportunity offender and talk about the bad old days of how things used to be in the robotics industry. And so the first topic is academia. At the end of the day, lots and lots of papers were produced out of academia, sometimes demo videos or other applications like that, but it was rare that the solution that was created was shared with the greater community. So you couldn't reproduce it, and most likely you couldn't reuse it, or only a small group of selected individuals could reuse it. And the image over here on the right, I think, is a good explanation. Most importantly, kind of the bottom center definition about the conclusion. The logical conclusion is, of course, I should start over and do this myself because I can do it better than the previous version. And when you didn't have the total picture, I understand that outcome. But with sharing economy that we live in today, you can hopefully come to something better. So then there's government. Government is absolutely critical for policy, for funding, for everything else that they do. But a lot of times the R&D outcome was this really cool demo, and nobody else could take advantage of the results of it. Again, the intellectual property was owned by maybe one company or shared with a small group, but it wasn't available to the broader community. And then, of course, industry, we're all working on what we are trying to sell, and so we come up with diverse solutions. Most of the time, that could frustrate the consumer because you have now to figure out, which tool is the right tool that I'm going to commit to for the next, 10 years. And so I didn't put a slide up on standards, but you can see how those three in the past could create this, comic of standards and how they proliferate and evolve, and maybe not always great for the consumer or the ecosystem that we're trying to operate more efficiently. And so open source is a way to help all of these previous challenges improve. So the robotics industry is at a launching point. Selena just told us about what's happening in the healthcare industry. It's true across pretty much every industry right now because of the capabilities in robotics and many other factors. So these are some statistics that I won't read through. You can see it, but I think the key thing that's maybe not on here is the density of robots that's also increasing. So Selena just said 200 robots in CGH, which is amazing. Globally, the average is 165 robots per 10,000 employees, so it's just under 2%. in a production system, a production environment, not in the home right yet. But under 2%, and this is all just growing, right? So we need to share solutions, create interoperability, and doing it in the open source way. I don't need to convince the people in this room because we're already using open source, but I will hopefully communicate through this. So yeah, another example of Wikipedia giving us great things. Here's a diagram I got from Wikipedia. So this is an example of, open source is available not just for software that we're familiar with and talking about here, but in fact it applies to many different applications, hardware, standards, etc. So specifically ROS. So yeah, I mentioned I'm from Open Robotics. We're the stewards of ROS, which is this diverse ecosystem of tools and utilities and algorithms, and the people in this room and the companies that are represented here to allow the acceleration of robotic development. And when we particularly talk about ROS, we use that word interchangeably to talk about the different open source platforms and reference designs that the community can use, which is ROS, the Robotics SDK, Gazebo, the robotics simulator software, and then now more recently OpenRMF for fleet management solutions or interoperability solutions. So ROS is not new. Many of you have been working, maybe some back all the way to the Willow Garage days in 2007 when it launched out of the Stanford lab. We're now, I don't know what this is, about 20 iterations or releases of ROS and into ROS-2. It's established and it's broadly used. A brief overview of some milestones in the ROS ecosystem development. So PR2, which is that first picture over on the left, was the first commercially available ROS-based robot. There was about 50 of them made and sold or distributed, and still a couple out there in the world today. In 2014, roughly, I was having a conversation yesterday with some folks about space ROS and NASA's use of ROS. So in 2014, NASA showed up to one of the ROSCon events and said, hey, we're using ROS in our Robonaut platform, and they hadn't talked to us at all about it, and that's the joy and the pain of open source, is sometimes you don't know who's using it or what problems they're having until you find out kind of organically somehow. And then, of course, in 2018, in Singapore here, catalyzed by Ministry of Health and National Robotics Program, A-STAR, we launched OpenRMF that Selena just introduced before to apply the concepts of ROS to connect hardware to develop robots faster, to now abstract up one level and now connect robots and systems to deploy them faster. In 2020, I can't remember exactly, but the first safety certified ROS-2 based solution for the automotive industry was released by APEX AI, APEX OS, I don't know, anyway. And then also, in the simulation tool, DARPA is an early adopter and active user of Gazebo. They ran the sub-T simulation that actually a few teams from Singapore were also part of, to run a physical and virtual competition for robotics development in search and rescue applications. It was a 4-year project, huge progress in robotics development, all based on the cloud simulation on Gazebo and using a lot of ROS tools, of course. So ROS robots are everywhere today. I think whatever domain you're looking at, whatever application, it's not just AMRs, it's not just robotic arms, it's everything and all of those things. And so we have outdoor delivery robots from Starship and Amazon Scout and many others. Auto Motors there in the top was a spin-off of ClearPath Robotics. They've been one of the earliest commercial adopters of ROS and still a very successful companies. I mentioned NASA Robonaut. It's also running, Robonaut is unfortunately not running on the space station anymore right now for some mechanical issues, not software. But the Astro Bees, which are these little research and development cubes, are on the International Space Station and available for universities and companies to do research on, and these are ROS-based robots out there. So every industry, every application, commercial robots, Sony Aibo is pictured here. iRobot recently publicly said that they're using ROS and ROS-2 specifically in their Roombas. So the largest commercial deployment of robots in the world is ROS-based. So it's ubiquitous. And it's in every market. So whether it's healthcare or industrial or automotive, et cetera, ROS is being applied. And the idea is, same with how we're applying OpenRMF, it is generic and it's extendable to the solutions that you need to apply it to your domain. And it's having a huge impact. I think the only number I'll emphasize is the one on the bottom left, which is just mind-blowing to me. So we talked about fuel at the beginning of the conversation, right? The digital ecosystem thrives with this diverse community of solution providers and products and companies and people, and known acquisitions, which there's probably a lot more that are unknown, but known acquisitions of ROS-based robots exceeded $6 billion. So that's a lot of energy generated from open source software, I think. And not to say that ROS is the only reason those acquisitions happen. Of course, there's lots of amazing products and solutions that are built on top of it and around it, but they can take advantage of that tool to build their commercial application. This is a little bit of a reference for you that are all in the ROS community about the size and scale of the community as it is today. So we did kind of a scrape of GitHub repositories, and there's 6,000 mentions of ROS topics and 1,000 mention of Gazebo topics. And you can see at the bottom some comparisons for some other popular frameworks that you're familiar with. It's certainly not as large, but it's growing every year, and it's amazing to see. And it's a Robotics. It's a global robotics hub. That's a local company. Of lots of different companies that participate and contribute and support the open source software that we can all take advantage of today. I'll talk a little bit about OpenRMF here. Since we're on the logo slides, I'll put this up. So this is again, what we know about people that either have been public in some way or have talked to us in some way about the community that's starting to use OpenRMF. I'm sure it's bigger than this, but it's fantastic to see in just a short few years how many folks are already up on there. On the left, we have the robot providers, so they're creating the platforms that are interoperating with each other and agreeing to communicate with each other in order to make the overall system more efficient. We have the infrastructure providers. Of course, if we're operating in a facility, we have to go through the doors and the elevators to make everything work. And so we need to be integrated with these, as well as battery charging solutions. The SIs and solution providers, the ecosystem thrives on all these different components that work in it. There's integrators and people that build services on top of RMF and sell those services and succeed, and it's wonderful. So that's the folks on the right side of the picture. And then of course in the center are the agencies and the enablers that are deploying OpenRMF in their different facilities and testing it out and funding research and participating and collaborating on the development. So I talked about the bad old days, but let's talk about the current times, even though I gave you a little bit of snapshot of that. So today, academia is different animal. You see lots of references. Most publications come out with the software behind it. It's very public in order to allow other researchers to reproduce what you've done, to build on it and take advantage of it. And what that's enabled in this example and the ecosystem that we work in is now we have robots that are or researchers and folks that are studying robotics that are able to work on a common platform from a classroom in their turtle bots or their racers, all the way through to production deployment. So it's building that resource pipeline of engineers that are feeding the companies that are capitalizing on the open source software. Government. So all the R&D programs are leveraging previous results. We take advantage of simulation tools in these examples. There's many international robotics competitions that use the same game engines to calculate how the teams score and the resources that are developed. There's ARIAC on here from the industrial competition, Sub-T, all the way back to DARPA Racer, somewhere on here maybe. Anyway, lots of different competitions in R&D, and they're using the simulation tools as well as the ROS tools underneath that keep getting developed. And we all love space, so a lot of the funding from NASA and DARPA research has been funded into what is now happening to launch ROS-based robots into space, which is just pretty awesome. So right now they're using ground-based solutions, but there's a push called Space ROS to certify ROS packages for space applications. So hopefully in the next couple years, we'll actually see ROS outside of the space station, maybe on the moon or somewhere else operating. And then industry. So I talked about the crazy growth and density that's increasing and the acquisitions that happened in the industry. Here's a couple that are highlighting, I guess, the commercial success of the companies that are building on top of ROS. And so, the most recent one, which really helped that $6 billion number, is iRobot over on the right. They just got acquired by Amazon not too long ago, 1.7 billion, which is amazing. So the community is building on it, and there's commercial success for everybody involved. So when you work in open source tools, I think these are probably questions that each of you have either asked or been asked, one way or the other. And it's common concerns. I hope that thinking about the number of companies that are using ROS and the number of solutions out there that are already using ROS and the work that we're doing to improve ROS, we can build that confidence a little bit with the folks that ask the questions. And I think the other thing to consider when you're facing these questions is we had a question yesterday about licensing software, for example. ROS itself or OpenRMF or Gazebo, whichever tool you're talking about, it's not a packaged black box solution that you just plug in and run with, right? And so it's got to be part of your overall product strategy. And you have to fit that into how do you secure your system? How do you make it easier for your users? What kind of opportunities can you create on top of ROS or Gazebo or OpenRMF to make it easier for your customers, for example? So yeah, open source is not perfect, never will be, but it's a great opportunity for business. So what can we do? The call to action. So wherever you fit in this chart, right, I think there's some opportunity for each of us to help open source grow, and in particular ROS grow. If you're in academic, of course, share your code and require that people that are working with you do the same. If you're in the government, you can prefer or require, if possible, that you have open source solutions or some percentage of your solution is provided open source so everybody can benefit from the research that was done. If you're in industry, you can set policies that require the use of open source or a contribution of some open source if you're leveraging it to give back. And of course, give feedback. Everybody can communicate and give feedback, contribute in different ways, right? Whether you're a vocal, whether you're giving feedback on what needs to be improved, that's helpful. Whether you're contributing in software code, whether you're funding one of the companies or buying from one of the companies that's using ROS, all of this helps everybody in this room to grow their business. And of course, if you didn't get a chance to go to ROSCon Kyoto, don't worry. The next one is in New Orleans, so it would be great to see everybody there. It's already announced, which is unusually early, so you can plan ahead. October 18th to 20th next year in New Orleans is the hopefully next ROSCon, right? This is the third attempt to go to New Orleans, so it's either going to work or it's cursed and we will never go there. I don't know. So let's see what happens. And with that, I thank you, and I'll answer any questions you may have.
So, any questions?
Thank you, localized Matt. I have a question, not so serious, not technical. I see a lot of turtles associated with ROS. Is there a meaning for that, or do you mean, or are you trying to hint that our ecosystem really moving too slow? Thank you.
Yeah, I actually don't know the history of the TurtleBot, so I will deflect on that question. But it is the common theme across all. TurtleBot is the reference platform that's been used from, for the past, 15 years to apply ROS and allow a low-cost learning platform. But beyond that, why was the turtle selected? I don't know. I will take some homework and go find that out. Does anybody know?
If you look at one of your slides, all the versions,
Yeah.
go back, everything is about turtle.
For sure. Turtle is the theme, but why is it turtle? Ruffin, maybe you know?
From what I can recall, I think at OSRF there was one of the developers that had turtle. And if you go back in the ROS.org archives, like Internet Archives, there's a photo of a turtle with this ROS sticker on its shell.
There you go.
I saw you call Gazebo digital twin. Can you elaborate on that? Because in my mind, Gazebo is a simulator, very different from a digital twin. Or is that the future for Gazebo?
Yeah, good question. So I think digital twin, from our perspective, is kind of a new term, or a term that's getting broadly used, I'll say. But at the end of the day, what we perceive a digital twin to be is a simulation of an environment or of a product. And so we're changing the language a little bit to align with what the community is saying. But a digital twin at the end of the day is a virtual representation of your product or your design. So Gazebo, in fact, was an early digital twin tool to create these worlds. So yeah, that's the reason. It's a robotics simulator for sure. It can use different game engines if you want different visualizations. Depending on how you define digital twin, it can be a one-way digital twin where you're just representing it in the virtual world, or it can be connected with a live system. But yeah, Gazebo can enable that environment the same as other digital twin software today.
Matt, for the presentation. My question is that now that ROS has gone so far and so big, and there's so big community, where do you then see the future of ROS moving forward? Let's say 10, 20 years down the road.
Wow. So I think ROS will continue to grow as it is. We keep adding more capabilities and tools into the ecosystem, whether it's interoperability solutions, or now AI and machine learning is a big push where some of those tools will start coming into the ROS ecosystem, more into the ROS ecosystem. I think another big push we're seeing from ROS-2, which will continue certainly for the next 2 years, is certified systems. It was very difficult to get a ROS-1 system certified. That's one of the motivations for ROS-2. And so we already see it with the Apex AI, the automotive certification. Space ROS is now going to be a space-based certification, medical, industrial, all these other domains where they prefer or require certified systems. I think that's going to be a big push in the ROS ecosystem in the next 10 years. So the certifying bodies are typically like, TUV or those types of companies. And then there's suppliers or service providers that can create a certified package using ROS. So with like the Apex example, what they did is they took a certain set of packages that are used for autonomous driving, and they did all the testing and documentation that's required for certification. So the software is freely available open source, but if you need to go sell a certified system, you need that test documentation, and that's the product that they're selling. I'm simplifying, but that's essentially what it is.
So I think Ross likes to draw parallels in terms of developing a larger community ecosystem, say like Linux. But you get to your certification. Are there other examples of certified open source software that are still very community driven, or is it always devolved with sort of that one vendor that provides a audited version of this open source product?
Good question. I don't know if I have a good answer for you.
We may be going in uncharted territory.
Maybe. I mean, the one that would pop in my mind would be Android community somehow, because I don't know the mobile phone development market, but I assume there must be regulations about whether it's FCC or whoever about how the software is operating within the devices. But I'm not familiar enough to say. But yeah, it's a good question.